Okay, so in number nine is actually the other problem that you had to do some calculus here. So I'm giving you the velocity, and then I'm asking for the formula for the equation for position and acceleration as functions of time. But velocity fits right in the middle, meaning that in one direction you have to do the derivative, and in the other direction you have to do the integral. So to do the acceleration, which is the simpler one because it's just the derivative, I'm going to have that my acceleration is the derivative of velocity with respect to time. So if I look up here, this is my equation for velocity. And with a trig function, it pretty much is going to be the derivative of sine of the angle times the derivative of the angle. So if I write what I have up here, I'm going to have negative 15. The derivative of sine is cosine, not negative cosine. The derivative of sine is cosine, so that means that the answer is still going to be negative. So cosine of 3t times the derivative of 3t. And the derivative of 3t is 3. So my answer is going to be negative 45 cosine of 3t. So that's your answer for the acceleration. Now to get the position, this is when I have to do the integral. So we have that velocity is the derivative. Okay, I can use the derivative of x with respect to time. If I say this thing is moving in the x direction, I can write the derivative of y with respect to time if I'm saying it's moving vertically in the y direction. Or I can just use the generic s, meaning it's a displacement in some direction. So I'm going to use that. So it's the derivative of s with respect to time. And so now that formula, my unknown is I want the s. I already know what the v is. So this equation has to be rearranged to have ds equals v dt. So that's when I rearrange that equation. ds equals v dt. So so when I write it again, ds, I'm going to replace v with what v is. So v is minus 15 sine of 3t dt. Now, here's the thing. Our formula for, like if I want the integral of the sine of x, so if I want, I guess I'll do it down here. If I want the integral of the sine of x, I need the sine of x dx, and that will actually equal, the integral of the sine of x dx will actually equal minus cosine x. So the integral of sine x dx. So I need the whole dx. Well, if you look at my problem up here, x is 3t. So dx dt is going to equal 3. And I want this. I want it to look like a sine x dx. So what I need in my integral is dx. So if I bring the dt over, I get that dx equals 3 dt. So I need a 3 that I don't have yet. So if I take the integral of both sides, and I'm going to put the integral right there because the constant part can be pulled out. I just want this. So what I want here is I want this to be sine x dx. Well, that is my x because I'm saying x is 3t, but my dx is 3 dt. So I need sine x dx. So I need a 3. I can't just put a 3 there without keeping it balanced. So if I'm going to multiply by a 3, I have to divide by a 3 out there. And so solving, the integral of ds is going to be s. And so minus 15 divided by 3 is minus 5. But the integral of sine x dx, you can see it right here, the integral of sine x dx is minus cosine x. So it's going to be minus cosine 3t. So minus is going to now make this plus. So plus cosine 3t. And whenever you take an integral, especially an indefinite integral where we don't have, borders here, like we don't have a start or an end, then the end part is always plus a constant. So this was our answer for A, and this is our answer for position. So we have, this is our acceleration equation in terms of time, and this is our position equation in terms of time. And knowing this, I can tell you what the maximum position is, and I can tell you what the maximum acceleration is, because the value, this thing maxes out when that's 1. I get negative 45. So the maximum acceleration is negative 45 meters per second squared. The maximum position, that part, see, because it's going to be oscillating back and forth around some equilibrium position. When that's 1, that's 5. So the maximum position would be 5. If I go back to the original equation, the maximum velocity would be negative 15 because the sine of 3t at a maximum is 1. Any questions with that?